Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 3, Section 4, Parallel Lines and the Triangle Angle Sum Theorem. Okay. So this section starts out with a theorem, the Triangle Angle Sum Theorem, which says that the sum of the measures of the angles of any triangle is 180 degrees. Okay. So the proof for this one I am going to do in class, but I do want to talk about the picture and why this is in this section. You might say, what does it have to do with parallel lines? And the reason why it's in this chapter is because the proof actually involves a construction, and we've never actually done a construction in a proof before, so this is going to be new. So what they did is they give you a triangle, ABC, and then if you notice at the top, they have a line, which we could call PC, and this line is drawn for us, so it's a construction. Now, when we do this proof, you actually have to construct a line that's parallel to AB. Now, in any proof, you're always allowed to do a construction as long as you can do that construction for any given that you would have for that proof. So for this one, we're given ABC. So for any triangle ABC I could ever draw, I could always draw another line that would be parallel to that would be parallel to line AB and go through point C. Okay? So this would be a valid construction. Now, you don't actually have to get out your construction tools and draw it. In your proof, what we'll do is we'll put it as part of our statements, and our reason will be construction. And so we'll say, construct a line, PC, parallel to AB. Now, you have to be careful when we start doing constructions like this in a proof. You have to make sure that your construction would be a construction you could do for any given that you would have for that proof. In other words, I wouldn't be able to say, construct line PC that would be parallel to AB and be perpendicular to AC. Okay? That would only work if my triangle was right. So we need to be careful when we make these constructions. So I will use that parallel line. It's involved in the proof, and we'll do that proof in class. Okay. So the next thing we have is just using the triangle angle sum theorem. This one involves taking a look at the three triangles and getting the angles we can. So if you take a look at the left-hand triangle, we have angle that's 39 degrees, an angle that's 65 degrees, and then x equals 180. And if we solve this, we get 104 plus x equals 180. Subtract the 104 from both sides, and x equals 76 degrees. Okay, so this is 76. Now the easiest way to get y then is just to use the fact that x and y are supplements of each other. So this is going to be 104 degrees. So y equals 104 degrees. And to find the last one, I think the easiest thing to do is to use the fact that this whole top angle would be 21 plus 39. So that was going to be 60 degrees. And then if we take 60 degrees plus the 65 degrees plus z, that's going to be 180. So this would be 125 plus z equals 180. Subtract, and z equals 55 degrees. So z equals 55 degrees, and we found all of the angles. The next part we're going to talk about classifying triangles. So this is all about different types of triangles. The first row has how to classify triangles based on angles. So if all the angles are congruent, it's called equiangular. So I can draw a triangle that has three congruent angles, and that's going to be equiangular. If all the angles are acute, then it is called an acute triangle. So I'll try to draw one that doesn't look like it's equiangular, but it's still. So that would be an acute triangle. We can call a triangle acute as long as it's pretty definitive that all the angles are acute. If one of the angles looks like it might be, right, then we can't say. We don't know if it's a right triangle, it's an acute triangle, or an obtuse triangle. Okay, so as long as the angles are pretty definitively acute, we can call it acute. A right triangle, this is one that has to be labeled. Okay, I can draw something that looks right, for example, and say, is this a right triangle? And right now we can't say it is because we don't know what that angle is. But if I put a right angle in it, now it's a right triangle. Okay. And then an obtuse triangle is one that has an obtuse angle in it. Okay. We can also classify triangles based on sides. We've got equilateral, which means all the sides are congruent. And one note about this is with triangles, this doesn't work for all shapes, but with triangles, if a triangle is equiangular, it is also equilateral, and if it is equilateral, it is also equiangular. One nice way to remember laterals, if you've ever gone in and used, like a fitness machine, there's a lat raise, so it comes from the word, it means sides, laterals, so equilateral means all the sides are congruent. Now, some books might have a definition that says exactly 2 sides are congruent, but our definition of isosceles is at least 2 congruent sides. So according to this isosceles definition, an equilateral triangle is also isosceles, okay, because it says it has to have at least 2 congruent sides. And then if none of the sides are congruent, so I'll put them in different colors, but then it's called scalene. Now, you can also make that black. You can also do this to show that it's scalene. You can make that like 1 tick, 2 ticks, 1, 2, 3, and that would show that it's a scalene triangle. Okay, and you can combine those. You can have like a scalene right triangle. You can have a scalene isosceles triangle. Or sorry, you can have a isosceles right triangle, or an isosceles acute triangle. So you can combine the sides and the angles to make definition of triangles. So classifying a triangle, if you take a look at this one, you can see by the tick marks that it's isosceles. And it's pretty definitive that the angles are acute, so I can say it's an isosceles acute triangle. Okay. Now, the other theorem we have is called the triangle exterior angle theorem. So before we do that, we need to talk about what's an exterior angle and this idea of remote interior angles. So an exterior angle of a polygon is an angle formed by a side and an extension of adjacent side. So if I draw a triangle and then I take one of the sides, so we'll take this side, and then we extend one of the other sides. So this side, we'll extend it. What we get here is an exterior angle. Now we can do that for any side and any extension of an adjacent side. Now, along with that, we get this idea of remote interior angles. For any triangle, there's always, for every exterior angle, 2 remote interior angles. So a remote interior angle are the 2 non-adjacent interior angles to a given angle. So if I take the exterior angle, there's one angle that's adjacent, that's inside. Can't be that one. And then there's only 2 angles left. So these must be the remote interior angles. So it's the 2 angles that aren't adjacent to the exterior angle. And then we have a theorem based on this. It says the measure of each exterior angle of a triangle equals the sum of its 2 remote interior angles. So the exterior angle is angle 1, so the measure of angle 1. And then again, this is the adjacent one, so we can't use it. The 2 remote interior ones would be 2 and 3. And so measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. And that ends today's notes. Thank you for watching. Have a great day.